Welcome to my algebra class. We're on chapter 8, section 8. We're going to be graphing linear functions, which are lines, and quadratic functions, which are parabolas or curves. A linear function is identified by slope-intercept form here, y equals mx plus b, or f of x equals mx plus b. It's the same thing. This is also equal to y equals mx plus b. And it's a straight line with a slope of m and a y-intercept of b. The quadratic function creates a curve, a U-shaped curve that either opens up or down. And it's called a parabola. If the number in front of x squared is positive, it opens up like this. If it's negative, it will open down. We're going to evaluate this quadratic function at several points and then graph it. So this is the value for x, and this is x squared minus 2x minus 2. So if I evaluate it at 0, I get 0 minus 2 times 0 minus 2, which is negative 2. So x equals 0, y equals negative 2. If I evaluate it at 1, I get 1 squared, which is 1, minus 2 times 1, which is 2, minus 2. So I get 1 minus 4, which is negative 3. So if x is 1, y is negative 3. If I evaluate it, let's do the opposite. Because the parabola, since it's squared, you should have the same values on either side. So if I do negative 1, I get negative 1 is symmetric. Negative 1 squared is 1, minus 2 times negative 1 is positive 2, minus 2. So I get 3 minus 2, which is 1. So if x is negative 1, y is 1. Okay, let's try if x is 2. Let's see what happens. If x is 2, we get 4 minus 2 times 2, which is minus 4 minus 2. So we get 4 minus 6, which is negative 2. So if x is 2, y is negative 2. And then if we evaluate at 3, we get 9 minus 6 minus 2, which is 1. So if x is 3, y is 1. And here's our parabola. It was supposed to open up, and it did, because it's 1 in front. And you can see it's symmetric. This is the vertex, what we call the bottom or the top, the minimum, or the maximum. In this case, this would be a minimum, the lowest value of the curve. It's also the vertex. Now this parabola is going to open down. So we can evaluate some of these points here. Let's try 0. So the opposite of 0 squared is 0. 2 times 0 plus 2 is going to give us 2. So x is 0, y is positive 2. If x is 1, we get 1 squared, the opposite, that's negative 1, plus 2. 2 times 1 is 2, plus 2. So you get negative 1 plus 2, which is 3. So if x is 1, y is 3. Let's try 2. The opposite of 2 squared is negative 4, plus 2 times 2, which is 4, plus 2. So we get 0 plus 2. So if x is 2, y is 2. So here's the top, and it's coming down this way and this way. This is the vertex, the top of it, so it has a maximum. And it did open down. Please understand my curves are not the best in the world. Okay, there is a way to find the vertex without graphing everything, and the formula, how they arrived at it's in your book if you want to take a look at it. Otherwise, you're going to have to memorize this. If I want to find the x value, remember this point has an x and a y value. If I want to find the x value, I use the formula, the opposite of b over 2a. And that's coming from the equation y equals ax squared plus bx plus c. So a is the number in front of the quadratic term, b is the number in front of the x term. So if I was looking at this equation right here, b is -2, so I put the opposite of -2 over 2 times a, and a in this one is 1, 2 times 1. So I get the opposite of -2 is 2 over 2, which is 1. And this was the value for x was 1. And then I would just plug it in to find y. So if I found x, just plug it back in here and find y. So y would equal a, oops, we have to get to the equation. Okay, going back to this, the equation was x squared minus 2x minus 2. So I put in the value of 1 for x, and then I can find y. So 1 squared minus 2x minus, excuse me, there should be a 1 there, minus 2, so the value of y is 1 minus 2 minus 2, which is 1 minus 4, which is -3. So our vertex is 1, -3, which was the vertex. If you go back up here, here it is, it's 1, -3. And the axis of symmetry is a line that splits the parabola into 2 equal parts, and it has to go through the vertex, and it's always a vertical line. So the formula for the axis of symmetry is just to set x equal, remember a vertical line is always x equals the opposite of b over 2a, so that has to be the x value of the vertex, x equals 1. Okay, with that in mind, we're ready to start the problems. So we're on 386, written 1 to 18, and problem number 2. It says, draw the graph of each linear function. You may wish to verify your graphs in a computer or a graphing calculator. And you could use the app Quick Graph on the iPad to check things if you want to. So number 2, I'm going to make a coordinate plane, and the equation is f at x goes to -x plus 1. So I'm going to turn that in the slope-intercept form. This can be just y. The arrow equals -x plus m. So in slope-intercept form, y equals mx plus b. The slope is -1, number in front of x, and the intercept is 0, 1. So graphing that, I plot x is 0, y is 1. And the slope is -1, so I go down 1, right 1, and connect that with a line. Remember, these are linear equations. They make lines because the exponent is to the first power of that x. Okay, problem number 4. We have d of x equals -3/4 x. So I'm going to replace d of x with y equals negative 3/4 x. So our slope is negative 3/4. There is no number after the term with the x, so our intercept has to be 0, 0. And we're going to graph that. So plot the intercept 0, 0, and the slope says negative 3/4, so that's down 3, right 4. And there's our line for that equation. Problem number 6 says n of x equals 0. That could be written as y equals 0. There is no x-intercept, there's no b here, so the intercept is at 0, 0. And the slope is 0 because there's no x term, so that's a horizontal line and it's the y-axis. Oops, little misty there. That's our answer. Problem number 7 through 12, we're to find the coordinates of the vertex. These are all parabolas, and then give the equation of the axis of symmetry and the least value of the function. Okay, so number 8 is g of x equals x squared plus 4. So remember, the standard form for a quadratic is ax squared plus bx plus c. And they first want, part A, they first want the vertex. So the vertex, we have to find x. X equals the opposite of b over 2a. So the opposite of b, there is no b term here. There's no x term, so it would be 0. X is 0. And then to find y, which is g of x, put in 0 to the function, and 0 squared plus 4 is 4. So our vertex is 0, 4. And if we go back and look at the quadratic, the number in front of x squared is a positive 1, so it opens up. So this, if it opens up, 0, 4 has to be a minimum. So the least value is 4. The axis of symmetry is, x equals the vertical line that goes through the parabola right here. That's weird. Is x equals 0, and the minimum is 4, the bottom of the parabola. So those are our 3 answers. Problem number 10, we have t of x equals 4 minus 10x plus 5x squared. I'm going to turn this around so we get it in quadratic form. Y equals 5x squared minus 10x plus 4. This is A, this is B. So first the vertex, the x value of the vertex is the opposite of B, which would be 10 over 2 times A. 2 times 5 is 10. So that's 10 over 10, which is 1. Now plug that back into this equation to find y. So y equals 5 times 1 squared minus 10 times 1 plus 4. 1 squared is 1 times 5. We get 5 minus 10 plus 4. 5 minus 10 is negative 5 plus 4 is negative 1. So our vertex, the x value is 1 and the y value is -1. So that's our vertex. The axis of symmetry has to be x equals the x value. It's going to go right through where x is 1. And since we turn this around, the y is positive, it's opening up. Vertex is 1, -1. So it has a minimum, smallest value at -1. So this is the vertex. This is the axis of symmetry. And that's our minimum. The axis of symmetry, remember, goes right through the vertex. Number 12. We have f of x equals 1/4 x squared. So first finding the vertex, x equals the opposite of b over 2a, and this is of the form ax squared plus bx plus c, so there's no b term, so it has to be 0. So we plug that back into this, so y equals 1/4 times 0 squared, which is 0. So our vertex is at the origin. So the vertex is 0, 0. And it's positive, so again it opens up. Looks like the odds are going to open down. So this is 0, 0. Our axis of symmetry has to go right through the vertex, so it's a vertical line. So x equals 0 is the axis of symmetry. And it has a minimum of 0. And the last set of problems were to find the coordinates of the vertex, give the equation of the axis of symmetry, and the greatest value of the function. So number 14, we have f of x equals 4x minus x squared. I'm going to turn that around to -x squared plus 4x. So first, finding the vertex, x equals the opposite of b over 2a. A is -1, b is 4. So we get 4, the opposite of 4 is -4 over 2 times -1. So we get -4 over -2, so that comes out 2. The x value is 2. We're going to plug it back into the equation. So y equals the opposite of 2 squared, I'm using this equation right here, plus 4 times 2. 2 squared is 4. That would be -4 plus 8, which equals 4. So our vertex is 2, 4. The axis of symmetry is the line that goes to the vertex, the vertical line, so x equals 2. And our parabola looks like this. Since the number in front of x squared is negative, it opens down. Our vertex is 2, 4. The axis of symmetry cuts it in half, equal sides. And since it opens down, we have a maximum value for the vertex. The top of the vertex is 4, or y is 4. Problem 16, we have k of x equals 1 minus 3x minus 6x squared. So we're going to turn it around, get it in the correct order, decreasing order. Negative 6x squared minus 3x plus 1. So the vertex, the x value equals the opposite of b over 2a. And this is b, and this is a. So we get the opposite of negative 3 is 3 over 2 times a, 2 times negative 6. So it's 3 over negative 12, which is negative 1/4. So to find y, we're going to plug in the negative 1/4. So we take negative 6 times negative 1/4, square it, minus 3 times negative 1/4, and then add 1. Negative 1/4 squared is positive 16, so we get negative 6 times 1/16. Negative 3 times negative 1 is positive 3/4 plus 1. So if we change everything into, well, we could go with 16ths. Negative 6/16 plus 12/16, 4 goes in the 16/4, plus 16/16. So negative 6 plus 12 gives me 6/16, plus the 6 there, I get 22/16, which is, simplifying, 11/8. So my vertex is negative 1/4 and 11/8. Its negative number in front of x squared is negative, so it opens down. Here's my vertex, negative 1/4, 11/8. The axis of symmetry goes right through where x is negative 1/4, so my axis of symmetry is x equals negative 1/4. And since it opens down, it has a maximum value of 11/8 for y. And the last problem, number 18. You have h of x equals 1 minus 1/3 x squared. Turn that around. So y equals negative 1/3 x squared plus 1. So there's no x term, so the opposite of b over 2a is going to be 0. Now we have to find y, so we substitute y 0 in for x here, so we get y equals negative 1/3 0 squared plus 1. So y equals 1, since that'll be 0. So our vertex is 0, 1. The axis of symmetry has to go through the vertex, and it's vertical, so x equals 0. And it was negative, so remember it opens down. So it has a maximum, and the maximum is 1. That concludes the evens. Be sure and check the answers in the back of the book for the odds.